Alright, so here's part 2 for the rest of this page and the third page. So you should have set up negative 7 squared plus y squared equals 25 squared, right? Length of leg, this is the hypotenuse, or the radius in this case of the circle. So you should have gotten the answer to be 24. You go left 7, up positive 24. That makes sense according to where that point is located in this coordinate system. Alright, the next one, hopefully you went ahead and moved on. You can see a very obvious right triangle right here. These are the two legs. Remember, the hypotenuse is opposite the right angle. So 18 squared plus y squared equals 25 squared. You get a answer of y squared equals 301. Take the square root. Well, it doesn't simplify, so you just have the square root of 301. Okay, moving on, Pythagorean triples. Some of you might start recognizing these Pythagorean triples and feel like you don't need to do the quadratic formula, the Pythagorean theorem anymore, which is fine. So these are the common Pythagorean triples, 3, 4, 5. So what does that mean? That means you have two legs that are 3 and 4 and a hypotenuse that is equal to a length of 5. But what you can do is you can double all of those values. So as long as you multiply a Pythagorean triple by the same factor, so this becomes 6, 8, and 10, then that's still going to work. It's still a Pythagorean triple. So we could make it 3 times 3, which is 9, 3 times 4, which is 12, so it could also be 9, 12, and 15, right? And we could keep going and going and going. Another common Pythagorean triple is two legs of length 5 and 12 and a hypotenuse of length 13, or two legs of length 8 and 15 and a hypotenuse of 17, or two legs of 7 and 24 and a hypotenuse of 25. Now, believe it or not, there is a relationship between the two legs and the hypotenuse, and it was discovered, so in 320 BC, Euclid developed a method of finding Pythagorean triples, and this is what it is. If x and y are positive integers with x being greater than y, then you can find one length of a leg by multiplying 2 times x and y. You can find the other length of the leg by taking x and squaring it and subtracting the square of y from it. And you can find the hypotenuse by taking those two, x and y, and squaring them and adding them up. Okay, so let's check it out. Let's try one. So you can pause now and do one on your own, or you can follow me. So I'm going to say let's make x 7 and y equal to 2. So are they both positive integers? Yes. Is x greater than y? Yes. So what does a equal? A equals 2 times x times y. So a equals 28. B equals x squared minus y squared. So it's 49 minus 4, so b equals 45. So right now I have a triangle with a side length of 28 and a side length of 45. Now I have to find my hypotenuse. My hypotenuse is the sum of x squared plus y squared. So 7 squared is 49, 49 plus 4, so that is 53. So now let's check it. So let's check it on our calculator. So I don't know if that works, or did I make an error? So we should be able to check, is 28 squared plus 45 squared equal to 53 squared? So this is where the Pythagorean biconditional comes into play, because if that is true, then this triangle that I created is a right triangle. So 28 squared plus 45 squared, I just grabbed my calculator. Does that equal 53 squared? Yes, it does. So 2,809 equals 2,809. So yes, these equal, so this is in fact a right triangle, and I did these steps correctly. So my A is 28, my B is 45, and my C is 53. Cool. All right, let's try some problems now in the back. So it says, it is quite rare to have three lengths that determine a right triangle. More often the case is that the three lengths create an acute or obtuse triangle, right? So you have many, many acute and obtuse triangles. So actually you can determine if the triangle will be acute or obtuse by using an extension of the Pythagorean biconditional. This method is shown below. So here are some formulas that are going to help you do that. But one thing you must take note of is that C is always the length of the longest side of the triangle. So in a right triangle, that C is called the hypotenuse. It has a specific title, and these other two, it does not. So C is the longest side, so if C squared equals A squared plus B squared, then it is a right triangle, and the triangle is right. If the longest side squared is less than the sum of the other two sides squared, that means it's an acute triangle. That angle is smaller than 90 degrees. If the largest side squared is greater than the sum of the other two sides squared, then that angle is larger than 90, which means it's obtuse. Okay, so we have the Pythagorean theorem, the acute triangle theorem, and obtuse triangle theorem. So this one's the Pythagorean theorem, and there we have it. So what do you do when you're looking at these three examples? You have to look at the largest number. So we're going to set it up. Is 41 squared? And I'm going to put a circle here because I don't know if it's an equal sign, a less than sign, or a greater than sign. 41 squared, how does that relate to 9 squared plus 40 squared? So just grab your calculator, add them up, and see what you get. So I'm going to go ahead and pause here and fill in the answers, and you should try these on your own. Okay, if you followed these three rules up here, or three theorems, you would see that the first triangle should have been a right triangle. The second triangle is an acute triangle, and the third triangle is an obtuse triangle. What did I do? I always took the largest of the three numbers, and I squared it, and I compared it to the sum of the other two numbers squared. If it's less than, it's an acute triangle. If it's greater than, it's an obtuse triangle. If it's equal to, it's a right triangle. Okay, and finally, specify all of the values of x that make this statement true. So here's a diagram over here, definitely not drawn to scale because we can adjust our values depending on what we get. So do not look at this and think, oh, it has to look like this. No, we're specifying all values of x, which means this diagram could change. Okay, so what do we know? We know one side length is 8. We know one side length is 1. This is referring to angle, this angle right here. And we know one side length is equal to x. So if we want to make this triangle isosceles, what do we need to do? Well, the definition of isosceles says two of those sides must be congruent to each other. So I could either do these two sides, so x could equal 8, or I could do what? And that looks better, but I said, again, don't go with scale. So, or I could do these two sides to make it isosceles. So if this is 6, what would x be? So my other option is that x would be 6. Okay? So that's number 1. Are there any other options? No. Right? It has to be 8 and 8 or 6 and 6 because I gave you those two values. Okay, what if we wanted a triangle to exist? Right? This is going back to that very first lesson we did. If we already have a leg length, a side length of 8 and a side length of 6, I have to make this triangle exist. So, meaning if I made x equal to 1, could this triangle even exist? No, it can't, because we found out the sum of the two sides of a triangle have to be greater than the third side. Is 1 plus 6 greater than that? No. So what do we do to figure out how to make a triangle exist given two lengths of a triangle? Well, we did the sum of those two things, and we did the difference of those two things. Oops. So what do we know? It can't be 2. 2 is still too small because it can't equal that. Could 2.1 work? Yes. So that tells us then that x has to be greater than 2, or could it be 14? You know, 8 plus 6 is equal to 14, or could it be 15 or 16 or 20? No, because 8 plus 6 is 14. Can it equal 14? No. And if it's any of these others, it's not greater than. So we have to make 14 the highest possible number, but it can't equal 14. So x has to be less than 14. So it's actually caught in between 2 and 14, right? X has to be in between the number 2, in between the sum and the difference of these two given numbers in order for that triangle to exist. Okay, if I want angle 1 to be a right angle, what must I do? If I want angle 1 to be a right angle, well then that makes x my hypotenuse. So I have to take 6 squared plus 8 squared and set that equal to x squared. 6 is 36, 8 squared is 64, so 36 plus 64 is 100, so x would specifically have to be 10. Is 10 in between 2 and 14? Yes, so we know that triangle does exist, and we know it's going to exist if it satisfies the Pythagorean theorem anyway. So x specifically has to be 10 for letter C. Okay, but how about for letter D? If we want it to be an obtuse triangle, I'm going to take my longest side. Okay, so that means this is going to be my biggest angle, which means this is my longest side. And I have to make x squared greater than 8 squared plus 6 squared. Okay, well we just said that 8 squared plus 6 squared was 100. So that means x squared has to be greater than 100, so x has to be greater than 10. However, that's not all we have to do. X can't be greater than 10, right? It has to be greater than 10, but it also has to be less than what? It has to be less than 14. So you have to put this upper end on it, right? So x has to be greater than 10, according to this right here, or it has to be less than 14. I said greater than 10 for this one because the mouth is open toward the x, even though it's a less than sign. So it has to be caught in between 10 and 14, because you cannot forget about this stage where we were trying to figure out if a triangle exists there. So then we reverse it. If we want the triangle to be acute, then it has to be less than 8 squared plus 6 squared. X squared has to be less than that, so x squared has to be less than 100, so x has to be less than 10. But again, can x be negative 1, negative 2, negative 3? No, we can't have a side length that's small. So you have to go back to this rule up here, which says x must be bigger than 2 but less than 14. The mouth is open toward the x, so it's bigger than 2 but less than 14. Right? So 2 is less than x, but x has to be less than 14. So if it has to be less than 10, it has to be caught in between 2 and 10, because it can't get any smaller than that. Just like here, it had to be got between 10 and 14, because it couldn't be any bigger than that. Can't be any smaller than this. So don't forget this stipulation up here. Those are tricky. Those hurt your brain if you really stop and thought about it. Try to go back and rethink about it again. You should have maybe paused and done that on your own. I should have encouraged you to do that, but oh well. Just have a think about it. Ask your friend, or ask the substitute, or ask another math teacher if you're still confused, and they can help you through it. Otherwise, really just stop and do the homework, do the stuff from the textbook, and if you don't have any issues with the homework, then you should be good to go for these sections. So next class is a video again, and you're still going to have your quiz next week. We're just going to see how you do. There's 2 quizzes this unit, so don't worry about it if you don't get through. I mean, if you don't do well, because there's another quiz, and remember your test can make your quiz grade go away if your test score is better than your quiz score. But you should still try to keep up, try to do well, and again, go see other math teachers if you're having difficulties. Have a good rest of the week. Enjoy the rugby if you go out and watch it. Enjoy your weekend, and I'll see you when I get back next week. Bye.